These notes are reviewing or looking ahead at our two special logarithms, what are called the common and natural logs. We are not going to use a calculator yet, so everything I do in these notes today is all techniques and strategies that you still need to know for the test or the quiz tomorrow. So converting, log properties, how to solve equations, etc. And actually, everything with the common log on the front side is all stuff you've done already, even way back to the first day of log notes. So remember that when you have log of x without any base written, it is understood to be base 10. And so I want to practice now that we have moved further with logs, not writing that base 10 when it's used. So for A, it says rewrite 10 to the negative 2 equals 1 over 100 in log form. So remember, that's your base, that's your exponent, that's your argument. So it would be log base 10, but now we're not going to write it, of 1 over 100 is equal to negative 2. If you do write it, then rewrite the problem without the base 10 or erase it once you're done. And then to evaluate log of 1,000, we had something similar in our notes the first day with this as well. And so on day 1, we set it equal to x, and then we converted to exponential form. So the base understood to be 10 would be 10 to the exponent is equal to my argument. And then when x is in the exponent position, we need to show like bases. And 1,000 is 10 to the third, therefore we know that that value is 3. Now, again, there's another way to do that using inverse properties, which I will do down below. So all log properties and solving techniques will apply to the common log as well. So if I ask you to rewrite something as a single logarithm, we always look for the power property first, and then we deal with the product and quotient. So I notice that I have a 2 that has to come back and a 3 that has to come back. And this hasn't happened in any of our examples yet, but there's a value in the argument that the 2 or the square has to apply to completely. So I'm going to write it that way first. It would be log of 10x quantity squared, and then minus log of y cubed. And then remember, minus is quotient, and I will simplify that 10x squared. So our final answer would be log of 100x squared over y cubed. And so there's our main properties, and then number 2 is going to be our inverse properties. So for the first one, I'm going to use inverse property number 1, which says if you know the base, which is understood to be 10, and you can rewrite the argument to be the same base with some power, the answer is just that power. And then inverse property number 2 says if you have a base raised to an exponent that is a logarithm that has the same base, then the answer is just the argument. So we simply just get 3 minus 12, which is negative 9. And then to our log equations. So remember, with solving log equations, you can have at most one term on each side. And so when we look at the first one, number 3, 2 terms, I need to combine. There's no coefficient in front, so I'm ready to deal with the plus right away, which is the product. So I'll multiply my 2 arguments together. Now I have one term on the left and one term on the right, and I notice it's log just on one side. Excuse me. So this is a type 1 equation. So we'll convert where the base is understood to be 10. So base to my exponent equals my argument. And if you automatically want to write 100 there, that's fine. And then I can subtract 16 from 100 and divide by 2. Don't forget to be checking your answer. And so remember for the quiz, that when you have a logarithm and your unknown is in one of these 2 positions, then you need to make sure that those both strictly come out to be greater than 0. So this one does. When I plug it back in for the x, I get 42 plus 8, which is positive 50. So that answer will work. And then to the second one, this one I do have a power for, so I got to bring that back. So it'll be log x squared minus log of 3. Again, it's okay if you do this next step in the same line as the one above. Minus means quotient, so x squared over 3. That's my get all logs or all sides to have one term. So one term equals one term. And once again, this is type 1 because there's only a log on one side. So understood base 10, 10 squared equals x squared over 3. And of course, again, that's 100. So if I multiply by 3 and take the square root of both sides. We're going to get x equals plus or minus 300. Now after break, we'll be using a calculator, so we'll just go right to whatever the decimal is of that. For now, since we don't have a calculator and that's easy enough to simplify, I will go ahead and do that. So it'll be plus or minus 10 root 3, and then before I circle my answer, I will go back and check and notice that it is x alone, and if I plug in a negative x value there, the argument would be negative, so I cannot have the negative answer. Don't forget on the quiz, I expect that you show both the plus minus and then show what the answer should be, whether you have to erase that negative or not. And then the last two, number 5 on the left, it's quotient because of the minus. There was no powers out in front or coefficients that came back as powers. And now one term on the left, one term on the right. This one would be type 2 because we have log on both sides and they have the same base. So when that happens, we can drop the word log and just set the arguments equal to each other. 12 is 12 over 1, so we can do some cross multiplying to get rid of my fractions. So 12x minus 12 equals x plus 10. Subtracting x and adding 10, we get x equals 2. Plug it back in. 2 plus 10 is 12, that's positive, good. And 2 minus 1 is positive 1, that's good. So I can go ahead and circle my answer. And then the number 6, no coefficients in front, so I'm ready to go with the plus, which is product. So it's going to be log of x squared plus x, or just squeeze it together to start. And then again, one term on each side, both have log base 10. This is type 2. So this is quadratic, which you will also see on the quiz tomorrow. So remember, quadratic, you want to get everything on one side equal to 0, and then factor. And this factors to x plus 3 and x minus 2, giving me two potential answers, negative 3 and positive 2. And when I plug it back in, the negative 3 doesn't work, only the positive 2 does. So that's our common log. Again, all things I think you could have already done, and some of them have been mixed in our notes and our homework already, and you've done them without even knowing that it's necessarily called the common log. The final special log that we're going to look at is what's called the natural log, and that is when it has base e. Now, you remember we looked at base e very, very briefly, enough just to graph it, and I told you we're just going to approximate base e to be about 2.7. And so when we look at this word log up here, when it says log base e, we tend to write the e instead of the 2.71828, etc. But even so, on a lot of places, books and internet and calculator, it's just not common to write log base e. So anytime they have that, you tend to see, and we'll practice as well, rewriting that as ln, which stands for natural log. Okay, this key concept box was already in our notes the first day with graphing exponential functions. Right below that is where I just want to call your attention, and that is just the practice converting between the two. So if you see ln of 4, that is just the same thing, that ln, as log base e. And then if you convert, it's base to your exponent equals your argument, which is why you see e to the x equals 4 over here. So if I take a look at number 1, and I gotta just change one thing in the bolds there. It says all log properties and solving techniques type 1 or 2 will apply to the, and then this side should say natural log as well. So converting, this is my base, this is my exponent, this is my argument. So it'll be log base e, which I'll change in a minute, of 8 equals x. And then again, it's not typical to write log base e, so we write ln instead. ln of 8 equals x. And the goal would be to go right from here to here once you have a better understanding of what natural log is. And then number 2 is just going in the opposite order. ln is equivalent to log base e. Again, nothing that you have to write, but if it helps, then you can clearly see what's the base, what's the exponent, what's the argument. So this would be e to the 2.1438 power is equal to x. That's just our practice converting. Then underneath is our practice with our properties before we get to equations. So I want to condense number 3a to a single logarithm. I see a power has to come back first, so that will be ln of 10 cubed or 1,000. And then minus means quotient, so it would be ln of 1,000 over 8. And again, after break, you'll have a calculator, so it would simplify further. But for now, just make sure you know how to do the properties with that base. B, there's some parentheses, order of operations apply. We should do the parentheses first. So bring those powers back. Again, this can all be done in one step. So I bring those powers back, and then I notice plus, which is quotient. So it'll be ln of b to the 5th times c to the 7th, and then we still have this ln of a out in front. And there's again the quotient, so our final answer will be ln of a over b to the 5th c to the 7th. And lastly, before the equations, these are a little bit harder to see because we're not that used to the word ln or natural log yet, but these are both the inverse properties. The first one is inverse property 2, and that's because we have a number base, or any base, raised to a log power that has the same base e, so the answer there will be 5. And the second one is inverse property 1, because remember this is log base e of e to the 7th, and when the bases are the same, that's just 7. So 5 plus 7 equals 12. So notice how all properties are the same, even with natural log as well. And last but not least, solving equations with the natural log. So for 4, I don't see any properties. Remember that ln is the same thing as log base e. So we have one term on the left, one term on the right. So we'll call this type 1 and we'll convert. It'll be e to the 3rd equals 2x plus 4. Now remember, e is just a number, so that's 2.7 cubed, whatever that number comes out to be. And again, we'll do that in the calculator after. Our goal is to solve for x. So I'm going to leave the e for now. We'll subtract 4, and then we'll divide by 2. And after break, we'll have a calculator to confirm that that's a positive number. And when I plug it back in, it will remain positive. So for now, you can just circle it. It will work. Number 5 has 2 terms. We got to combine those first. No coefficients, just plus means product. So it'll be ln of 4x squared equals 1/2. And then we have one term equals one term. So type 1 again, where we convert. Remember, this here is just log base e. So it's e to the 1/2 equals 4x squared. And if I solve for x, we'll divide by 4 and take the square root of both sides. Don't forget, especially for the quiz, when you take the square root of both sides, you need plus minus. And then, yes, I know that simplifies further. Okay, you shouldn't keep a square root of a 4 because we could take that out. We shouldn't keep a fractional exponent, but after break, we're going to go to the calculator anyways. So don't worry about that right now. All I want you to see is we can only keep the positive answer. And that's because when you plug in the negative value, even though we don't know what the decimal is, we can see right there it can't be negative. Number 6 has 2 terms on the left, so those need to be combined. It's quotient, x over x plus 2. And on the right, we have a coefficient in front, so it needs to come back as a power. So it'll be ln of 3 squared, which is 9. One term on each side. This is type 2. So we just set those those arguments equal to each other. Cross multiply, just like a similar earlier example. 9x plus 18 equals x. I'll subtract 9x. I'll divide by negative 8. And that will reduce by 2 to negative 9 over 4. And then I check it. And it's x alone up here, and x alone cannot be negative, so we need to cross it out. And since there's no other answers, we would say no solution for this one. And last but not least, number 7, natural log, no coefficients, so it's just the product because of the plus. One term on the left, one term on the right, type 2. Natural log on both sides, I could drop the word log and set those two things equal to each other. Quadratic, so get everything on one side equal to 0. And then try to factor that. 2 numbers that multiply together to give me negative 71. And add together to give me 70 would be positive 71 and negative 1. Giving me negative 71 and positive 1 as potential answers. Plugging both of those back in to check, the 1 will work, but the negative 71 will not. Okay, after you're done watching this video, you can go ahead and start the homework, which will be due after break as discussed in class. Have a great rest of your day.